looking at a table that has to do with a field trip, okay? Let's refresh our memories from Friday. What's the domain, or what are the x values of this field trip? 75, 68, and 125. Okay. What's the range? 2 and 3. Okay. I did not list the 2 twice because we only need to list it once. Okay. That's the only place that it goes. Right? Okay. Now, we said the definition of a function is if each domain has one range. Okay? To me, the easiest way to see that is in one of the mapping diagrams. Okay, we're talking about 68, 75, and 125, 2, and 3. Okay? 68 goes with what? 2. 75 goes with 2. 125 goes with 3. Why is it not a function?
2 numbers go to the same.
Okay.
75 doesn't have a y value.
Okay, well, it has a y value of 2, but it doesn't go to maybe one that's not being used. Is that what we're saying?
Yeah.
Okay, let's read the definition of a function again, somebody. Off your paper. Each domain has one range. Okay. Does 68 only go to one range? Yes. Does 75 go to one range?
Yes.
Does 125 go to one range? So why is it not a function? It is a function. Mm-hmm.
Oh, so if would it be like if 68 and go to 2 and 3, it would be 1?
Right.
Okay, I gotcha. But how would it go to 2 and 3 though?
All right, well, let's look at the next one.
Oh,
Okay. So on this one, our domain is 7, 9, 12, and 15. Our range is -1, 0. Whoops, I'm sorry. It was in order. -7, -1, and 0.
Oh, I get it.
I think it's a -7. Okay, so if we were listing this as a set of ordered pairs, 7 goes to what? It goes to -1, and it goes to 0. Okay, so do you see how this 7 goes to 2 things? So is this a function? No. Does that make sense now?
Yeah, how did we know that it went to 0?
Because it gave us the mapping diagram, and we just read the mapping diagram. Okay? If we wanted to list the coordinates, we could say, okay, 7, -1, 7, 0. 9, -7. 12, -1. 15, 0. Does that make sense what I just did? Okay. Yes and no?
First it didn't, but when you explained that, they already know it's correct.
Yeah, they already gave us the mapping diagram. There was no trick to it.
How do you find it? Yeah, how would you map that?
Like a mapping diagram? They've already done it for us. This is the mapping diagram.
Oh, what if they give you like one of those like grid?
Okay. The half triangle?
Oh, no, it's like this. It's not closed.
If they gave us like the graph of it?
Yeah.
Okay, hang on. This one's got negative, so I need to do it XY and go in all directions. Okay, it would go over 7 down to -1 and 7, -7, and then you'd have 9, I'm sorry. 7 went to -1 and to 0. And we have 9, -7. You have 12, -1. 13, 14, 15, 0. Okay, on this one, the best way to tell that is to take the points off of this graph and put them into a mapping diagram. Or I could show you a shortcut.
Wait, so what if they don't give you that?
If they don't give you which thing?
The the one to the left?
They're going to give it to you either in a table, in a mapping diagram, or in a graph. And because we know how to make all of those things, or they might give you a list of coordinates. Because we know how to make all those things, you could figure it out. Okay?
Like, I think what I was asking, if you kind of, but I think I'm asking, if like the graph on the left, we can tell that 7 goes to 2 different
Mm-hmm.
numbers, but on the graph, how do you tell if the number goes to 2 different numbers?
Because you look at the x value and see if it goes to 2 things. Like if we go over, this is the x-axis. If we go over to 7, do you see that there's a point at 7, 0? Here, where I just colored in green? Do you see that there's a point at 7, negative 1? Okay?
What if they just give you that, though? How would you figure that out?
You could either just look at it and see it, or you could write a list of coordinates. Looking at this graph, if I write a list of coordinates, there's one at 7, 0. There's one at 7, negative 1. There's one at 9, negative 7. Thank you.
So if there's anything between 1, it's not.
Right. Where was it? 15, 0?
Oh, and since 7 shows up twice.
Right. And if you can make a list of coordinates, then do you also have the skills that you need to make a mapping diagram? Yes. Okay, so if they give you a graph, you have the skills it takes to make a mapping diagram. Hunter? Okay. Yes, that's our mapping diagram. Okay, now let's look at C. Okay, this is kind of what we were asking before. We'll look at these two at the same time. On the first graph where I tried to make it a perfect circle. I know it doesn't look like it, but it is. Just pretend. On this one with this circle, all right, there's a lot of coordinates in there, an infinite number, because we could go to any point on this circle and say the coordinates, right? All right, so let's go back to what we did on Friday. What's the domain of this graph? Is it a set of points, or is it going to be continuous?
Continuous.
It's continuous. It's going to be an inequality. All right, what's my highest point on the x-axis?
4.
4. Okay, my highest point on the x-axis is 4. What's my lowest point? Negative 4. Okay, then what do I do to make my compound inequality? X in the middle.
Greater than.
Less than or equal to, less than or equal to. Okay, now our range. Okay, what's my highest point on the y-axis? 4.
Negative 4 plus 4.
Negative 4 and positive 4. Does everybody understand what we just did? Okay, now how do I tell if it's a function?
It goes to more than 1.
Okay, so pick an x value that's on this graph. Pick an x value between negative 4 and positive 4. 3? All right, if I go over to 3 and I look at 3, is there more than one coordinate at 3? What are they? There's 3,
Yeah, there's 5.
2.5,
Yeah.
and 3, negative 2. If it was perfect, it would also be negative 2.5, but it's not perfect. All right, so is this x value used more than once? Yes. Pick another x value.
2.9.
2.
1, 2.
If I look at 2, is the value of 2 used more than once?
Probably, yeah.
Yeah, it's used at 2, 3.1, and 2, negative 3.1. This one was a little better. The x values are used twice.
And that makes it
Not a function.
teamwork.
But so the x value, if it goes to more than 1, it's not a function, but if the y value goes to more than 1.
All right, now I know that how many people, Hunter and Ethan, were willing, they wanted the shortcut, right?
No.
If you don't want the shortcut, you don't have to look, but it's kind of the same thing I'm already doing. Do you see on this graph, I drew a line to help me look at 3, right? A vertical line. Can you see that vertical line? Okay. I drew a vertical line to look at 2. How many times did my red graph hit that vertical line? Twice. Okay, that is called the vertical line test. If you draw a vertical line through the picture and it hits more than once, not a function.
Well, that was.
So go ahead and look at this one. Is it a function?
No.
No. Because what happens if I draw a vertical line through that parallelogram?
Is that all you're gonna ask for?
It hits twice.
Is that all you're gonna ask for? Is no function or not? So
Yeah, you could say, I will, like, the directions on this section were, give me the domain and range, tell if it's a function.
So you don't have. So how do you do it?
All right, well, let's do that. That's what we did when we picked out the highest and lowest. Okay, on this one, what's the domain?
1 and 2.
All right, on the x-axis,
Oh, no. That. Okay.
on the x-axis, what's my highest number?
No, it's not 3.5. No, 4.
4. What's my lowest? -4. Okay, x in the middle, and make it a compound inequality.
All closed shapes not.
Right.
What if it's not?
We'll do one of those in just a minute. All right, let's talk about the range. What's my highest y value? 1. Whoops. What's my lowest y value? -2. Y in the middle. All right, so that part we've got. Is it a function? No. We did the vertical line test, and we said it is not a function. Okay? All right, let me see if I can copy this. All right. I don't know. I didn't read the email. All right, let's take this graph and look at it. All right, what if I had, remember back in the days when we were doing functions and we said like y equals x squared? Do you remember what the x squared graphs look like?
No.
Well, let me remind you.
Oh yeah, the V stuff.
Is that a V or a U? All right, it's U-shaped. Now, if we draw a vertical line through here, how many times did it hit? Once. If we draw it over here, how many times did it hit? Once. If we draw it over here, how many times does it hit? Is it a function?
What if you drew it sideways?
Yes.
That would not be a vertical line test.
Yes. Is there horizontal?
There is no horizontal line test. Okay? Let's talk about another one. All right, if we did...
It gives you that graph.
I got a question.
Mhm.
So if it's x squared,
Did it you?
Mhm. All right, Steven.
you know how that V was like that? What if the V goes?
If the V went if the U went sideways, is that a function?
I would say not, but then again.
No. Okay. Let's look at a V-shaped graph, which are the absolute values ones. Is that a function?
Yes.
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 Okay.
Yes.
How about just a line? Is that a function? Yes. See, don't you like my shortcut this time?
Yeah.
Good. All right, what about, let me give you a discrete graph.
Oh.
Function?
No.
Yes.
Yeah. Okay.
No.
Function? No. Yes.
But what happened if like it was like a check mark line and it went through the class like on one part but it went through one the other?
Like this?
Yeah.
Okay, this one still goes once everywhere. But what you're saying is if the graph was like this.
Yeah.
Okay, his question is right here, it passes the vertical line test. But right here, it fails.
That's not function.
It's not a function. If it fails the vertical line test anywhere, it's not a function. Because look, if we went to the x value of 1, how many times is it used?
What?
Twice, and that can't happen. Okay?
Which is more common?
Yeah, we're going to take a little quizzy quiz tomorrow.
Which is more common? The function and
So much fun.
For what we're doing, it's going to be probably 50-50. All right?
Right, where you got y equals x squared, are we gonna have to write
No, not yet.
because like, I think I've got like identifying the graph and the x and y and all that good stuff.
Yeah. Okay. Let's come back. Remember I told you to remind me I wanted to come to this graph, or this little box.
Yeah.
Let's fill it in. Okay? A relation is a function if, what's the shortcut I just told you?
Vertical line.
Passes the vertical line test.
A relation is.
So we just right does not.
Are you going to know what that means if you just write V line in your notes?
Yeah.
Okay.
What, are we gonna have to like name it in the test?
Vertical line test? No. I just want to make sure you know what you're talking about. And it's not a function if
It doesn't.
it fails the vertical line. Okay? And in technical terms, not using the shortcut, it is a function if what?
If it is a function, it's if the domain has a range.
Each domain has one range. Echo, echo. It teaches the vertical line test in another lesson,
What,
but I don't see why not introduce it here.
is it a function if it has two ranges? No.
Okay, so let's fill in the second box. Not a function if a domain has more than one range.
Or it doesn't.
When are we gonna use this in the real world?
What's our real world situation?
If you grow up to be a math teacher.
There you go.
Because that's what I was planning on.
Cardiologists can use graphs to analyze their patients' heartbeats.
Yeah, because I'm going to be a cardiologist.
You never know.
Even a week ago, you said you're not even gonna go to a Spanish-speaking country.
That's right, and you never
But
know.
I have an interpreter.
I hope you got money to take him with you.
No, because